At the beginning of this lesson, we were introduced to the function y equals 2x plus 1 times x plus 3. In order to take its derivative, what we had to do was multiply the two binomials using the distributive property. We obtained y equals 2x squared plus 7x plus 3. Then we could take the derivative using the power rule, and we obtained y prime equals 4x plus 7. Could we have taken this derivative in another manner? Well, we now know the product rule. The product rule could be used to find the derivative of this particular function. It is not the most expedient manner to do it, but we want to show that you should end up with the same derivative at the end of the whole process. The product rule states that y prime is equal to f of x times g prime of x plus g of x f prime of x. So what we have to do is take our function and define what f of x and g of x are. We're going to let the f of x represent the 2x plus 1, and g of x will represent the x plus 3. So our first line, we've stated the product rule, and now we are going to fill in the appropriate portions of that product rule. F of x is equal to 2x plus 1, so that's filled in. G prime of x is the derivative of g of x. Well, g of x is just an x plus 3, so its derivative, g prime of x, is just 1. We add to that g of x, which is the x plus 3, and we multiply that by f prime of x. Well, f of x is 2x plus 1, so its derivative, f prime of x, is merely a 2. Then it's just a matter of expanding and combining like terms. So we end up with, in our second last line, with a 2x plus 1 plus a 2x plus 6. Combining the like terms, we end up with y prime is equal to 4x plus 7. This is the same derivative that we obtained using the power rule. So we can show clearly that the product rule or the power rule could have been used in this particular case to find the derivative of this function.